Hey, in this episode, we'll be just trying to solve some LeetCode problems, basically three problems from LeetCode, and I'll just pick some problem and try to solve that. So for today, let's pick a medium problem. Okay, this one. So this is a binary tree zigzag level order traversal, and they're giving the root as a parameter and then expecting and vector of vectors as the return argument. So if you see here, they have given the tree. So basically what they are expecting is to go in a zigzag manner. If you take let me show you. So if there's tree like this, so basically what they want to print, what they're asking to print is they want to go like this, not like this, not like this. So they want to print this in such a way that alternate levels are reversed basically. Okay, so yeah. So what I'm thinking is we can do a level order traversal and we can just reverse the even levels. As I said, we can basically do a BFS here. BFS basically means the level order traversal. Okay, so we'll traversing this level by level. At least this was the first solution that came into my mind. Okay, so we will try to optimize that, but for now what I'm thinking is we'll try to store every level and we'll reverse every level. So this will go like this every level, right? And then we will try to flip this, so reverse this alternate levels right here, and just reverse this one, right? So of course for BFS, I will be using Q. If you are familiar with STL in C++, and then I think it would be easy for you to just import that Q and implement that. So yeah, actually, what I'm doing is I'm having a notebook with me. So I'm just trying to write down the code instead of instantly going into the monitor. So this would be a good practice if you're trying to solve. Just try to solve using a notebook, pen and paper. That would be really helpful for you in interviews. So yeah. So just right now I'm just trying to implement this BFS function and trying to get the elements of same level. So basically, single BFS is actually pretty much straightforward. You will just try to pick up elements one by one. But if you want the levels as well, you must modify the original BFS a little bit. Okay, it turns out that I think we can do this using a single queue, where you can maintain like some delimiter to differentiate levels, and for every level we want to store that in a vector queue. And I think if the level is odd, then we would reverse that level. In this case, level is nothing but it's just another vector. Each vector is a level, right? So it's like a 2D matrix. Each row is a level. Okay, so I think we can start implementing this function. So let me tell you the way how this queue is used here. Okay, so there is a tree like this, let's assume, right? So there's A, oops, C, D, E, F, and G. Okay, so we have a queue with us, and the first thing we'll be doing is we'll be pushing this root node, which is A. We push this, right? And after that we also push a null, just another null value in. So this null value represents that another level is pushed here. So this is the end of one level. Okay. So the front of the queue is this, and we'll start from here. So if this is a not null value, excuse me, if this is a not null value, then push the children of this node. So the children of this node is B and C. So we'll push B and C. Okay, and then pop this one. So I'll pop that, and the front will be this. So this is a null value. So what we'll do is, if this is a null value, then we'll push the null value itself here. So you can see that so the BC is in a separate level now, and A is in a separate level now, and this will move forward. And similarly we'll push the children of B, which is D and E. So D, E, and then again we have an ordinal value, which is C, which is the children, which is F and G. F and G, and after that again we have a null value. So we will try to pop this and push the null value itself. So this goes on until we the size of the queue is greater than 1. So until it's greater than 1, we just try to run this queue in a while loop. Okay, so let's see. Let's try to implement that first. So first I want a queue of type tree node, because if you want to check the left and right value after popping the front, so it needs to be a node instead of an int. So let me push that root, and as we talked about that, we will also push a null value before starting the queue. Okay, so now as we have talked here, we have the first root node and another null node we pushed into this. So now we can run the loop while queue.size is greater than 1, right? So as we talked about this, we have to run this queue until the size is greater than 1, because we'll be having a null element at the end remaining, and it won't just pop out, so we would never reach the size 0. So that's the reason we are putting the size as 1 here. So I think we can get the top node, let's say tree node, it's a top, or front is a queue.front, and pop that, right? So we have got the first value here, so we are getting the front value from here, right? So now we have to check this, the value which we have popped right now is a null value or not. So we'll check that here. So if fr, which we have popped right now, which is the front of the queue, is equals to null, or we can say is not equals to null first. We'll check that condition. I want to do something else. If it is a null value, I want to do something else, right? So if it is a not null value, I just want to, if for example we'll take this node here, a, this is a not null value, so we have pushed the children of a into the queue. Okay, so before pushing them we have to check if they are present or not. It's a typical BFS here. So if fr pointing to left is present, then push that fr pointing to left, and similarly if fr pointing to right node is present, then push the right node. Okay, and if the given value is a null value, then what we will want to do is, according to this problem statement, what we need is we need to reverse this. So even before reversing, I want to just store everything into a type of vector of vector. Okay, so that's the result we are going to return. So first let me create a variable of vector v. So I want to push these values, the each level node elements value, right? So maybe whenever I encounter this null value, I will push the vector inside that, right? So for that I would just want a temporary vector, let's say temp, int of temp, and every time we the front value which we encounter, if front is not equals to null, then what I want to do is I want to push that into val. I want to push that into this temporary vector, and when I encounter this null value, I want to push this temp vector into this, and inside this loop, after pushing this temp vector, I just want to clear everything in that. So I'll do clear. So let me tell you what's happening here. Yeah, so we are having these nodes, right? So I have a node A. So first I encounter this, and after that I encounter a null value. So what happens when we start from here, right? This is the root value. So what I am doing right here is that I have created a vector temp, which is an array basically. So I have an array, and I'm pushing these front values until I hit this null value. So right now a is not a null value, so I just push it into this array, and I go to this position. So this is now a null value. So I want to push this entire array into a matrix, right? Because they are expecting a vector of vector int. So that is a 2D, which is an array of arrays. So maybe I will have some column rows like this. But what I want to do is I want to push this as the first level. So this would go here, right? A. This is the first, this is the first level we are having here. So after this, I don't want to reuse this, I don't want to reuse the same level elements. So what I want to do is I want to clear these elements inside this. So just remove this, and I would start pushing from the next elements. I'll just start pushing the new ones like B, C, and then I'll be pushing this here. They will go here, B, C. Again, when we encounter a null value, we'll remove the elements in this. So this removing of elements is what I'm doing here, temp.clear. Okay, I'm pushing the array, I'm pushing this here, and then I'm removing this here. So that's what's happening. So right now we would be having I think we'll be having all of the levels in here. And now what I want to do is, let me show you. So I have the elements like this. Let's assume BC, DE, FG. So let's assume these are this is a level order we got, and with indices 0, 1 and 2, right? So the resultant should be alternate levels should be reversed, right? So they would be expecting this, like A, C, B, D, E, F and G. So yeah, what we would be doing is we'd be going through each row, and we'd be checking the index of that row. If it is an odd index, we would reverse all elements in that. If it's an even, we would just leave it as it is, and that's how we'd be doing this to this entire array. So here this is an odd row, so we'd be reversing into we'll be reversing this row. If it's an even, we'll be just leaving as it is. Okay, so for that I want to go from 0 to, I want to go till number of rows, which is v dot size, and for each I want to check this t. If t mod 2 is 0, which means t is even, I want to continue. Or else you can just make it more simpler by saying if it's an odd, then I want to reverse this. You can say actually reverse if you have been using STL. I think you can do that using v of t dot begin, v of t dot end. So finally I'll be returning this v. So here v of t is if it's an odd index, the v of t is the complete row at that index. Here v of t is, so this is v of 0, this entire array, and this is v of 1, and this is v of 2, right? Okay, so let's try to run that and see any possible errors. Okay, so we got an error. It is not giving the desired input that we assume. So let's see what's the problem here. Okay, I think I found out the solution. I found out the problem. So we were talking about pushing an element, and after that we will be pushing null for each level, right? But we are not pushing any null for any element here. So that's what I want to do here. I want to check whether I am pushing the null element or not. So here I would just push null into this, and let's try that. Okay. Okay, so the problem that I found is that the index is going till only just, I mean, it's not going to the end of the level, so that's a problem. We are getting the desired result till the last but one index, but the last index is gone, so we have to look into that. So let's try pushing this outside. Um, okay, so we are getting. I think the instead this loop was not going until the last index, so that was a problem. Let's try running on few custom test cases, like what happens when we send an empty or a null value of root. I think we didn't handle that. Yeah, because if there is a no root, you have to just return null, right? So this is because it's vector of vector. So if it's a vector, we would be sending just this, and since it's a vector of vector, we'll be sending a double braced result, right? Okay. So let me try to submit this. Okay, so that's the first problem, and it's faster than 79.34. So let's calculate what we are doing here. I mean, the space what we have used. So we have used a queue here, and which should be going through n nodes. At a single time, I think it would be maximum of. I think it's 2 power level, right? It's 2 power level number of nodes. So what I mean by that is, if the level is 0, it has only one node because it's 2 power 0. If the level is 1, then it would be having, the queue would be containing 2 nodes because it's 2 power 1, and so on. So that's no problem there. We are using our two variables here, which is one v and temp. I think this might be more efficient, but I think that's okay. So let's see in the discuss is there any better way to do this. Okay, so using dq. Okay, yeah, so this guy is using a flag. So when he's just alternating the flag using flag and no, just making the flag opposite for every level, and if it's 1, then he's pushing front, or else he's pushing this. So it's dq, yeah, as I said, it's dq, pushing front and back. So yeah, we can do that instead of reversing. So for that you have to create a dq instead of what we have created, that's a q, right? So okay, let's pick another problem and dig right into that. So yeah, I picked this problem. Actually I have not submitted before this, so this is a new problem that I'm even seeing now. So this is sum of nodes with even valued grandparent. Okay, so given a binary tree, return the sum of values of nodes with even valued grandparent. So yeah, so grandparent is a node. um, Grandparent of a node is the parent of its parent. Okay, if there are no nodes, return 0. Okay, so I think what they are asking is that if this is an even node, then every child of its child's child should be added, right? So if this is 6, then we would be adding 2 plus 7 and this and this. So since 8 is there, we would be adding 5, right? So actually I have a small doubt regarding, is it okay if no, I think that doesn't happen because I was thinking if this could go like, we can is there any possibility of adding these 2 times, or it must be an unique addition? I think for these are unique for this grandparent, right? There's only one grandparent, so yeah, that's unique. Okay, so let's work on that. Okay, so one possible thing we can do here, I think, is that we can just check if there's a left child. Show that. So I think if so, there's a tree like this. Okay. Yeah. So there's a tree like this. This is a even node, and this is a even node. Let's think. We'll color with that with blue. I'm sorry, actually, I'm using a mouse and not exactly able to do this. Okay, so this is an even child. So what I'm thinking is possible is that I would check if there is a grandchild node for this and this. I would check if it is there, then I'll just add that, this plus this plus this plus this. So even before checking this, we would have to be checking like if the nodes left is present or not. But if a node is null here and we try to check if its grandparent somewhere is null or not, it should actually have a child, right? and that child is a grandchild for this. So if there is no child, then when we check this, then we can't check the child of this node, right? It would be throwing us runtime error or segmentation fault, because we are trying to get the address of something that is not existing, right? So we might also have to check first if this node exists, and then a child for this node exists, right? If that is true, then we would add this to the sum, and we would do this similarly for um, all the four possibilities here, which is left left, left right, right left, right right. Okay, so this I think this code is actually tedious, because this has a lot of code to write. We have to check this node first and then this, again we have to check this node and then this, and similarly for the other two as well. Maybe we would have some recursive solution for this, that would be more simpler. What I thought when the first time I saw that, what I thought was, a grandchild is nothing but let me show that. I will remove this. A grandchild is nothing but someone, some node who is in the next level of its child, right? So if this is level 0, level 1, level 2 and level 3, then level plus 2, then all the nodes are the grandchild of this node. For example, if you take this node again here, so 1 plus 2, which is 3. So from this node, every child in the level 3 is a grandchild of this node. So using this using this proof, we can actually create some recursive solution where we can add these elements up. Yeah, let's try to do that. Okay, try to come up with a pseudo solution that's a recursive solution actually. As I said, I would be sending I would be creating a function which would take the root and also the level with it, and this might be some function, right? And if there is no root, I would be returning 0, and if the level is equal to 2, I would say why that's 2. If the level is equals to 2, I would return the value of that root, right? So value of that root, and here the base case, and not the base case, the exact thing I want to return is this function for the left node of the current node, and I would do level plus 1 plus the same function for the right and level plus 1. So yeah, let me explain this with I know that's quite messy out there. Okay, so let me have this tree, some tree, not the exact tree we need. This some tree, let's say I have an node here. So this is even and this is even, let's assume. So what I would do is I would start from here, the function, the root which they gave me, and I'd be checking for every traversal or every node. I would be checking if the value is even or not. So if this is even, then what I would do is I would call this function for this root. So what that would actually do is it would actually traverse to the left and right of its subchildren or children, and it would go. I would be sending 0 as the default one, and the level will be increasing as we are doing here, level plus 1 for the left and right nodes. So we go here with level is 1 now, and when we are 1 we won't stop, we'd be going deeper, and we go here again, it's 2 now, the level is 2, and here if the level is 2 I'll return the value. So I'll just return the value here. Similarly I'll return the value here. So that is what's happening here. So the left and right would be calling itself, and they would be adding, and the sum which we have added would be recursively be returned to the root node. And similarly that would be happening to every node. We would be checking that to every even node in this tree, and I think that would be pretty good enough solution instead of writing a long code. I have not tested this actually. Let's write this and then test that. So let's go step by step. The first thing, if there is no root at all for this given tree, I want to return 0. That's the base case. And for every node I want to check if the value, the node's value or the root's value is even or not. So if root pointing to val mod2 is equals to 0, if it's 0, then what I would do is okay, so let me have a sum variable here, initialize to 0, and I would do sum plus is equals to let's say solve grand. Listen, this and okay, this is a level. Actually we will start with 0 as I said, and we would recur this for both the left and right children. So that's root for left, and root for right, and finally I just want to return the sum which we have gathered here by calling this function. That function is what we mainly need. That would be returning an int and sol grand. The type is tree node because it's a root node, or it's of type tree node, and the level. So if there is no root, I would return 0. And as we talked about this, if the level is 2, I would return the root's value, and finally I would return solve grand, root pointing to left, which means I would go to the left tree, increasing my level, and I would add that to solve grand, the right subtree, increasing my level, which would be returning this total sum. Okay, so I think let's compile and see if it's working or not. Okay, so we are getting what we need, and we test for some custom cases, like as we have tried this before. If there is no root, should we return 0 or should we return anything else? Actually should okay, yeah, it's 4. Let's see. Okay, it's reading. So let's try to submit this. Okay, so actually it's surprising because it got accepted the first time. So it's pretty fast because it's 95 point more than faster than 95 point some 63%. So I'm trying to see if we can avoid this sum variable. Is there any way to directly return this value instead of just adding this and returning the sum value? Because usually it's good practice to avoid global variables. So that's what I'm thinking. So let me do something for that. I mean, if there's a possible way, I think there must be a possible way if even we have to modify the function. So yeah, that's it, guys. Thank you for watching, and do like and share and subscribe if you like this. So we have solved two medium problems, which was the first one was quite implementation heavy, and the second one was a bit tricky. But yeah, if you find the base concept or the base case, I think it would be easy for you to build recursive solutions upon that. So yeah, thank you for watching.